easy one. Let's just go through this maximum odd binary numbers. You're given a binary string S that contains at least 1. You have to rearrange the bits in such a way that the resulting binary number is the maximum odd binary number that can be created from this combination. Return a string representation of the maximum odd binary number that can be created. Note that the resulting string can have leading zeros. Yeah, so basically 1 has to go to the end and the other ones should go to the front. That's basically what it is. I think what we can do is turn the string to a char array, and we will go from right to left, right? And then we check if we find the first one, and then we'll swap with the right, okay? And then after we've done that, the remaining ones will swap with the front. Everyone we find will swap to the front. Everyone we find will swap to the front. Or you have two. Yeah, that's actually going to be easier. You have 2 pointers. One is on the right, one is on the left. And as you go, you just keep swapping the ones to the left, right? Just keep going to the left. And on the left hand side, you will also move forward, right? Until you find the first known one. So by doing this, you'll be able to move all the ones. I think it'll be easier version. We just sort. All right, we just sort the array. We sort the array in reverse, and then we pick the last one. No, we'll sort it increasing. Then we can find the first one, we swap, and then we reverse it, then we return it. So do we have in Java reverse a array? Is there a thing? Don't tell me to loop it myself. You're kidding me. Oh my. Comment alert. Alright, what is this? Oh, collection or reverse. Oh yeah. Alright. You're gonna have to, yeah, it's the same argument. Okay, does Java has find the last occurrence of a character? That is not what we want. Find the index. Okay, find the index of the last occurrence in an array. Something like that. Oh, there is last index of. Perfect. That is exactly what we want. Hold a second, we need to make directory. I still haven't set up the debugger for the Java. I just, sometimes just, there's a lot of things, sure, and then also you just got lazy. Just get lazy. You get sidetracked because there are other things, a lot of competing things to do. So we can say char array equal to s dot to char array, right? And then can we say arrays dot sort this, and then I want it to be sorted in reverse. So comparators dot reverse. Actually, I don't know. I'm guessing. Sort array reverse. How do we do that? Collections dot reverse order. Okay, collections dot reverse order. Okay, collections dot reverse order. Okay. The reverse order. All the ones on the left, zeros on the right, and then we need to find the last. I need to find the index, right? We need to find the index. So int index are equal to array dot last. Oh, that's not right. What is the call? Oh man, that's array list. Ugh. Does not work. Oh my goodness. Yeah, doesn't work. Sometimes you just have to loop it yourself. All right, we'll loop it. For int I equal to array dot length minus 1. Okay, I large equal to 0. I minus minus. Right. If array I is equal to 1, we'll say array I was equal to 0, right? And array dot length minus 1 equal to 1, and I will return. I'll break. Okay. And return string array dot toString. Actually, I'm not sure. How do I turn a char array into a string? Char array to string. What are you guys talking about? String dot value of. Okay, string dot value of. String dot value of array. Okay. We can write some stuff. Do you remember the name? 286 something. 64. Pretty good. Memorized almost all of them. All right, now we just need to see if it's correct. Okay, throw in some. Right? Just some random stuff. Ooh, I cannot sort char array. What? It says I cannot. Wait, can I or can I not? Arrays dot sort. So can I write one myself instead of using this? Can I say AB and then character dot compare AB? Probably put a negative. This is my guess. Nope. Alright, I have no idea. No clue. Say I have. Okay, I have no idea why. What was wrong? I think it's because of this, right? Okay, so I need to reverse it. Sort char array descending. You define a comparator and pass that into this method. Oh gosh. Yeah, you have to turn it into a character and then sort. Do we have a string reverse? String builder are reverse. All right, so I'll shift the method. Okay, so it doesn't support directly. So I'll just sort it, and then because I sorted, I can find the first one, right? Then I can just say array dot index. Oh, it doesn't have index of, right? Shoot. It does not have index of. So I have to, oh my goodness. We have to do it by hand. At least I don't know how to do it. Not by hand, right? If it's this, then this one equal to 1 break. And we can say string builder. Right, string dot value of array dot reverse dot to string. Is that right? Is that what that one says? String builder hi reverse. Yep, I think that is correct. But we do have to do new. Okay. A lot of Java usage. What? Oh, shoot, plus. My bad. Oh. So should be good. Okay, first day. Sorting and swapping, yeah. Oh, counting ones. Ah, that was smart. Counting ones is smart. One pass, 2 pointers. Nah, it's not necessary to do it that way. All right, so we're gonna just have some vacation right now. Just have no easy one. Maybe hit another someone, you know. Okay, faulty keyboard. Your keyboard is faulty, and whenever you type a character on it, it reverses the string that you have written. Typing other character works as expected. You're given 0 index the string, and you type each character of S using your faulty keyboard. Return the final string that will be present on your laptop screen. So when you type I, you will reverse. So STRI will become RTSNG. Very interesting. Very interesting. So reverse and reverse. Okay, so as you type, once you hit the first one, it will reverse. Okay, and then you keep typing, so you have to keep adding. Let me see. So you add str, right, and your I. So you put N and G, right? And then if you reverse again, hold a second. You type STR, then you reverse, right? Then you should put N and G. And then you reverse again. So actually it's this, right? N and G. Then you reverse again. So it'll be G and STR. Right? You reverse again, then you start putting here. So each time you reverse, you start adding here. Reverse again, you start adding here. Reverse again, you start adding here. Right? So you have a deck, and you just start da 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 da. Once we hit a reverse, we can call it, you know, append on the front. Then you just start doing this. Append on back, doing this. Append on front, append on back, and eventually append on front. If it's append on front, we have to return it in reverse style. If it's a return on back, we just do it regular. Okay, so that's how we're gonna solve this. I think this should be Python, right? Yeah, we agreed that this will be Python. But Python, does it have? It does. It does. It does. Something called Q A deck. Okay. Then we just say for append front equal to append back, right, equal to true. And then for letter in S, if letter is equal to I, right, but basically say append back equal to not append back, else if append back, then q dot append letter, else q dot append left letter. Right, at the end, we will return, we say rest will equal to dot join q, right, and we'll return rest if append back, else without reverse, right? Wait, it doesn't have reverse. I actually forgot how do we reverse a string. I think it's this way. I think it's the same. Oh shoot, it's not else if. I have enough confidence. Actually, I should have tested more. But I guess that's fine. Okay. Okay, this one's done. Swap. Deck. One more. Let's do one more. Check if it is possible to split array. You're given an array, nums of length n and an integer m. And you need to determine if it is possible to split the array into n non-empty arrays by performing a series of steps. Do we have a typo here? I don't think so, right? But it says n non-empty arrays. Each step you can select an existing array, which may be the result of previous steps, with a length of at least 2 and a split into 2 subarrays. If for each resulting subarray at least one of the following holds: the length of the subarray is 1, or the sum of elements of the subarray is greater than or equal to m. Then true if you can split the given array into n arrays, otherwise return false. Okay, so what we want to do is to split the array nums into 2 arrays, into 2 subarrays, right? So split into 2 subarrays. If each resulting array at least 1 of the following holds: the length of the subarray is 1, or the sum of the elements. So if you have a length of 2, it will always be true, right? If you have a length of 2, it will always be true. But if you have a length of 3, then you'll have to split 1 and 2. Then you have to make sure that the 2 can add up larger or equal to m, right? And then if you have a length of 3, right? If you have a length of 3, again, because each split you will need to try, because each split you can split anywhere, right? You can split anywhere and then you can turn the problem into an easy problem. But at the end of the day, and the point is, at the end of the day, you will have to. So that's what I'm thinking. You can always just split out one of them, right? You can always just split out one and the remaining, right? So that's your first step. And then that's like kind of greedy. Every time you split out one, every time you split out one of them, and you always do it the smaller one, right? You always do the smaller one. Then the remaining, you can have a sum. We have a prefix sum, so it'll be easier for us to keep track. The question is, will this always be the optimal way to split? So you're saying there might be some situation. Is it possible that if we split this way, we get one value and all the other values? Will that fail, okay, so if that fails, which means all the other value put together is the both sides are smaller, then no, you know what? I think it works. I think it works, right? Because if it's gonna fail, it will just fail. There's no other way. Can't help it. Okay, so what we need to do is we'll create a prefix sum, right? Because we need to quickly access the total sum. And then each time I pick the smaller value, and then we'll try to remove the smaller value, and then we'll check the bigger side if it's larger or equal to m, right? If it is, then we just go, and then we keep going. So it's like kind of two-pointer solution, right? It's a two-pointer solution. So two-pointer solution, two-pointer solution. Ugh, I knew it. I didn't know it. Still not the most, oh my goodness. Not the most proficient. Okay, so we're gonna have 2 pointers. We're gonna have to have a accumulate. See, it didn't know accumulate. Func tools. No, it's a tools. Right, so we're gonna say psum equal to list accumulate nums. Okay, so now we have this, and we have I, j equal to 0 and 0, len nums minus 1, while I smaller than j. Then we can say if nums I smaller than nums j, actually smaller equal to, because fine, smaller equal to j, and psum, so I is smaller equal to j, so the psum should be j minus psum I, right? Psum j minus psum I is larger or equal to m than I plus plus. We remove I. Aleph nums I is larger than nums j. And so nums I is larger than nums j, so we remove all this. So that's just psum j minus 1 is larger or equal to m. Because at least the size is, oh, num length could be 1. Oh, if num length is 1, then we already get out, right? So that's fine. That would be j minus equal 1. Else, right? If neither satisfies, which means doesn't matter I and j, we just have those are smaller than m, then we just return what? False. Otherwise, we return. Oh, is that right? Give it a shot. It's all right. False, false, false. I got all false. Oh, yeah. So we have, okay, so while that's j minus I is larger than 1. Okay, true, false, true, false, false, true, false, true. Oh, interesting, the last one. Okay, so I remove 2, then I have this. It's the same. Oh, it's the same, and then we have the same value. In my case, I remove this. Now I'm, oh, wow. Okay. That is interesting. That is very interesting. So when you are the same, which one do you remove? Huh. Good call. Good call. Because if you have one big, one small, yeah, you definitely remove the small one. But you have 2 is the same. How do you decide? Why removing the front is bad? Because you remove the front, the total becomes small, right? Because it's 332. You remove the rest, also 332. But, maybe there's a choice here. Maybe there's a choice. You know? Maybe there is a choice. Maybe it's a DP. Right? Maybe it's a DP. Because you have to choose. You have to choose. Alright, so the DP, so DPIJ, so from I to J, is it possible? Right? Okay, so, yeah, we have to change idea. That's okay. I mean, it's normally how this happens. It's alright. So, def DP I J. Alright, so this will return a Boolean value. And we don't do this. And then all of this will go here. Actually, this one probably go here as well. Alright, so if j minus I is equal to 1, smaller or equal to 1, right, return true. No problem. Otherwise we say, we don't do this. If this and this, then we return DP, because I plus 1, J, right? I'll lift this. Oh, that's not right. Out of this, we return DP. This one will be I, J minus 1, right? Okay. So we don't need to else because we have to consider them anyway. So we can just say if, right? And then this if is going to be if nums I equal to nums j. Okay, and p sum, j minus 1 is large equal to m. Right? If it equal and j minus 1 is larger than m. In this case, we have to choose. So return dp either I plus 1 j or dp I j minus 1. So one of these, we have to do both. If neither, none of them, then return false. And I'm pretty sure we have to go also with functools import cache. Right, so cache this. Then we return p0. Okay. Now I turn this problem into O(n squared). dp, where dpij is whether it is possible to split nums I to j into j minus I plus 1 number of subarrays. The tricky part is when nums I equal to nums j. Alright, let's give it a shot. Damn it. So I remove this. That's 1 to 1. Then I remove. Oh, shoot. Yeah. Blah, blah, blah. Blah, blah, blah. If turn dp I j minus 1. Oh, can we combine them? Okay, so if this smaller than this, and if this bigger than this, and shouldn't this just be good enough? Why you make it so much more complicated than it needs to be? Alright, just smaller equal to, a larger equal to, we just include equal. Nope. Nope. So if I remove this, I have 2, 1, 1, right? Oh, we should also try both, actually. Because there is a possibility that both will work. Okay, so we say res equal to false. Then we say res what equal to dp I plus 1 j, right? And or, alright, so res equal to res or yeah. Does this work? Don't think it works. We will figure out why. Okay, so again, it's the last one. So yes, and a p sum j minus p sum I, which is this part, larger is true, so I can return dpi plus 1 and j. So in this, and with this we have 3, and then we say this is smaller equal to no, so this is larger than this. So should be returned false, right? So the first one should be false. The second one should also be false. Where did the true come from? Because if I remove the last one, right, j minus 1, okay, so remove the last one. And then dpi and j minus 1, right? And this one, nums I smaller to nums es, and then it should be 3, so it would be false. Actually 3 is also false. How do I get to a true? That is bonkers. Absolutely bonkers. Like how? I don't know. Let's debug. Let's debug. Good use case for debugging. Right. A lot of things have changed. Yeah, I have no idea what happened. So it seemed to me that everything was working as expected. Of course, it's not as expected. That's why it's wrong. All right, so we have what, 1, 2, 1, 1, right? All right, 1, 2, 1, 1, 4, and a false. Yeah, I have no idea what happened. So nums and m can split array. All right, we just do, let's put no configuration selected. Okay, so we'll go F2. So P sum is good. Go inside. I probably just step into. Wait, hold a second. Let me do F2. IJ is 0, 3. 0, 1, 2, 3. Okay, 0, 3. M is 4. Right? The rest is false. Yes. Then rest or DP. So now it's gonna be 1, 3. Okay, 1, 3. 1, 3. So jump. Okay, yeah, this is larger than this. I should also jump. Oh, I see the problem. Yeah, my bad. It's not this. It could depend on I. Should be minus P sum. Oh, I plus 1. Right, I plus 1. No, I minus 1. I minus 1. Oh, rah, 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 rah. If I is larger than 1, else 0. And larger than 0. Yeah, forgot the prefix sum. Man, debugging is really useful. It's like one of the most useful tools out there. There you go. That's the one. That's the one, my false, expected true. So I get this, 925. Holy crap. Oh, I see. Okay, all right. All right, boys. All right, boys. We have to I know what's wrong. I know what's wrong. So we just do this. If this is good, right? And if this is good, then we just do this. We don't check. Yeah, we already went down for DP, so we should just check all the situations. Don't even think about like, oh, I'll pick the smallest. There's no such a thing. Okay, there's no such a thing as the smallest. You just go ahead, right? You just go ahead, and it's okay, right? It's okay. It's fine. Just go right ahead and try the two sort of situations if it's possible. I wonder if I can do this. Can I do this? Would it tell me that it's not allowed? I mean, it is true and false. I'm not sure. Actually, I'm not sure. I am not sure. Can I have a try? I don't have this. I know I have here. Can I have a try of, let's say, res equal to false, res or equal to true, res. Oh, yeah. It works. That was good. Yeah, so I'll do it this way. It'll look nicer. All right, submit one more time. Come on. This time. There we go. This time works. I mean, it's all in squared, so it's expected to be a little bit slow. All right, let's take a look at what people say. ON. Oh my god. ON. I'm going for ON squared. All right, so they tell me there's an ON solution. How are you gonna ON it? ON. Because what I'm saying is you have to check both situations. But what they say is I can't. But how do you know which one if you go ON? Yeah, especially with this, right, with this one. Because this is big, but I choose to let this one go. No, I choose to let this one go, right? And then I choose to let this one go. And then, wait, how does this one work? Has to be larger or equal to 12. Huh. I don't know how this one works. Oh, I let 9 go. Right? And then I let 2 go. And I let another 2 go, another 5 go. But why? How did you decide you let 9 go? Yeah, I actually don't know. Good. Learn. This case is only possible if there are two consecutive numbers whose sum is greater than or equal to m. That's interesting. Because if we have this case, then we can simply remove all previous post numbers one by one. But if this is not present, then there's no way we can divide all the elements. Where we have 3 numbers left and none of the 2. Oh my god. Oh my god. Yep, did not. That was brilliant. Ha! That was brilliant. Yeah. So it's alright, alright. Alright. It's okay. It's okay. So this should be 2. Inspired by the solution in the forum. There must be an adjacent pair whose sum is larger or equal to make the array splittable. If no such adjacent pair exists, there will be no way to split the array once it reaches the size of 3. Yeah, make perfect sense. So what we need to do is for I in range 1 to len nums, if nums I plus nums I minus 1, right, is larger or equal to 0, m, return true, otherwise we'll return false. And it will be on. Yeah, this is a IQ test. Oh my goodness. Yeah, I forgot. Once it's smaller than 2, automatically it's good. Oh, look at the difference in time. ON is so much faster. Jesus. Good solution from that guy. All right. Let's just try one more. Find the safest path in a grid. You're given a 0-indexed 2D matrix grid. Right? 2D matrix grid of size n by n, where RC represents a cell containing a thief if grid RC equal to 1, an empty cell is 0. You're initially positioned at cell 0, 0, which is top left corner. In one move, you can move to any adjacent cells in the grid, including cells containing thieves. The safest factor of a path on the grid is defined as the minimum Manhattan distance from any cell in the path to any thief in a grid. Return the maximum safeness factor of all paths leading to cell n minus 1 minus 1. An adjacent cell is in 4 directions. The Manhattan distance is the Manhattan distance. So we want to find from top left to bottom right. There are many paths, right? There are many paths from top left, bottom right. And each path will have a safeness factor, which is defined as the minimum Manhattan distance from any cell in the path. The minimum Manhattan distance from any cell in the path to any thief So each path can have a bunch of Manhattan distance. So what I want is the minimum Manhattan distance. Is that 0? Worst case? They go through the thief, right? It goes through the thief. Yeah, that's 0. In this one, the minimum Manhattan distance is 2. Okay, so safe factor, the maximum. Oh, okay, so for each path, the minimum Manhattan distance from any cell is its safe factor. But we want to find, it's a min-max, right? I want to find the maximum safeness factor of all the paths. So we want a path whose minimum is the biggest. Basically that's what it means. So we want to stay away from the thief. So we can grab the indices of all the thieves, and we can start. Basically, each position has a cost, right? You can think about moving to the next position. It has a cost, and the cost is the distance, and we want the distance to be big, right? So when we move to the next one, we want to maintain it to be as big as we can, and then you move to the next one, you want it to be as big as we can, right? You always want it to be as big as we can. And if you move to the next one, will lead to be smaller. Well, but you have to, right? You have to. Like if you don't have anywhere else to go, and you need to reach to the bottom. Maybe you can just BFS this. You start from the top left, right? You BFS. So the first step, go here. Second step, you can go, just don't go back, right? Don't go back. Do not go back. I mean, you can go back, but what you want is you want to keep track of the minimum distance of the path. Right, you want to keep track of the minimum distance in the path. And you have many paths. Right, you can have many paths. So from the start, I can go out. Okay. From here, I can go out again, but I just don't go back. And I go out again, I can go here. So what I can do is I can get there are many paths. $400. Maybe what I can do is like starting from something and tell me the minimum that it has from this position if we want to go to the bottom right. Yeah, so we want to try to avoid. And that's a good problem. It's a good problem. Right, so basically we'll have costs. I still like this idea of cost. All right. I don't think I have enough capacity in me to keep going. I'm yarning really bad, but I do want to get a cost. So the cost, these are 0. Rewards. Let's call it rewards, right? So that's basically 1, 2, 3. Right. This is 1, 2, 3. Manhattan distance. 2, 1, 2, and then 1, 2. This is 3, and this is 2. This is 2, and this is 3. All right. So what we want is to stay as close to the maximum value as possible. So we start from here, and then our destination is here. So each time we go, yeah, I can pick the biggest one so far. Right, I picked the biggest one so far, and then I choose the bigger one, and I can choose a bigger one. And I choose this, but if you choose this would be better, right? So how do you decide which one to choose? And you cannot just the path. Well, I can't BFS, right? So we start from 3, and then each time we get in, that will be a path, and it will have the current minimum. So it'll be 2, right? It'll be this node with a 2, this node with 2. And then it will go down to this and to this. Then there will be a 1, there will be a 2, there will be a 1. And this one will go down. Doesn't matter because it just, they go down and they go this way. They become even smaller. But do you go back? You don't go back, but I can foresee that you might need to like turn around type of thing. Right? But why would you turn around? I don't know. I say we just stop right here and then we deal with this tomorrow. Let's think about this. Okay? Alright, that'll be it. I will see you guys tomorrow. Adios.